Hi guys, so I'm just going to pick up from where we left off last time, and I'm going to modify our formula just a bit to suit the application part of it. So we ended off by saying that f of, the gradient is equals to f of x2 minus f of x1 over delta x. And our graph was such, point A, where this is x1, so this gave us f of x1, x2, 4b, f of x2. Now, we did mention that this is change in x, and that this is change in y. So now the modification comes from us then saying, okay, why don't we just express everything in terms of just an x? So we'll take again still our point A, still our point B. So we'll say let this be x, which means that this will become f of x. And let this point be, because we say that this difference is delta x, so this becomes x plus delta x. So that this then becomes f of x plus delta x. So this is still delta y. And from our formula, let me just grab it here. Using this graph, we'll then end up with our f2, use a different color, being this one, which is f of x plus delta x minus f of x1 over, still the difference between the two is delta x, because x plus delta x minus x is still delta x. So this is the gradient formula that we're going to use. Okay. Now, if we continue with this, we'll see that if we're given a function, for example, f of x equals to x squared, then our f of x plus delta x is x plus delta x squared, which if we expand, we'll get 2x delta x plus delta x squared. So substituting it into this formula, that will give us x squared plus 2x delta x plus delta x squared minus x squared all over delta x. And upon removing brackets, or square brackets in this particular case, we end up with this, but if you take note, these two will subtract each other, leaving us with like that. And if we separate this, because we got a common denominator, then this can cancel out, leaving us with 2x plus delta x. But our priority, remember, was to say that this delta x is supposed to approach 0, then we'll be able to get the gradient of the tangent. So this will approach 0, leaving us with 2x. So in other words, if our function is x squared, then the gradient is given by 2x. That's it. Then let's look at other examples in the next video.